Hello everybody, so today I will talk about calculus. The topic today is the minimum value. Given that x plus 2y plus 3z equals to 50, find the minimum value of x squared plus y squared plus z squared a when x, y, and z belongs to real number and x, y, and z belong to integers. So I will show the technique how to answer the question. If you see that x squared plus y squared plus z squared, that's about the distance between O and O in here. That's about location of coordinate O, S, Y, Z in here. So we put about 30 in here, and plane is about this is about the plane in here. With A belong to the plane. So in this situation we have x, y, and z. We don't know, so we need to find the distance of OA, and this should be like this. We have x minus 0 and we put about the square. Similar for the y, similar for the z. So we will got the distance OA is about x square plus y square plus z square. So if we want to find the minimum value of this one, so the distance of OA should be about distance of A or distance of O to the plane, and the plane that's about this one. So we can find the distance in here. So we have D, O, and about alpha. We put alpha is about the plane in here. Because we have the 50 on the right, so we put the 50 go to the left. And now we have the formula of the plane in here. So we put about 0, 0, and 0. So we got about 0 plus 0 plus 0 minus 50. And now we have coefficient of the plane is about 1, 2, 3. So we have 1 square plus 2 square plus 3 square. This is about the formula to find the distance of one point to the plane, and we got about 50 over the square root 14, and this is equals to for this one. So because the distance in here from point A to the alpha is about the minimum value of this one, so we just put about the square in the both sides. And we will go about the minimum value, and this is about 1250 over 7. So in the question A, we don't need to find x, y, and z, but on the question B, we need to have the value of the value x, y, z from the question A. So that's why we need to use another one. So we need to have the equation of line OA. So because we have the normal vector of the plane is about 1, 2, and 3, so the line of the OA in this situation, we have x equals to t, y equals to 2t, and z equal to 3t, and this line they go through to the point O. That's why we don't have the number next to the t. So we put 3 number in here, back to the planes, because we want to find the value of t. So after we find the value of t, we can find the point of the A in here. That's about this one. So we have t, 4t, 9t, minus 50. So we can get the value of t in here. That's about 25/7. So after we find the t, we can find the value of the A in here. On the question B, they want to find the integers. So in this situation, we need to find the integers close to x, y, and z. So let's do about on this way. We need to divide the number in here, and we got about 3.5. This one we got about 7.14, and this one we got about 10.7 something. So that means that we can put S can be about number 3 or number 4 somewhere. So we have 7 for the Y, and we have number 10 somewhere to the Z in here. So we choose the highest number because we have 2 and 3 is about the highest coefficient, so that we can compare to the S. So we can find 4 couple of Y and Z in here. So we have 7, 10, or maybe 7 with 11, and then we have 8 with 10 and 8 with 11. So we put this number back to the plane in here, and we just put all the number from this one to find the S. For example, if Y equals to 7, so we have Z equal to 10, so that we can find the S in here is about 50 minus 2 multiplied with Y, that's about 7, minus about 3Z, that's about number 10, and we will go about the value in here. Let's see about number 6. We just keep calculate until we find the smallest S in here. So we have 7, this is about 11. So this is 11. and this is about 3. So we change y to the a. This is go to a. And this is about number 4. Now we change to this one to a and 11. And this is about number 1. After we calculate about the s in 4 situations, we can see that this number and this number, they very close to the x, y, and z. So we can reject this one, and we reject. Now we put back to x squared plus y squared plus z squared. We need to compare two situations here. So we have s is about 3, y is about 7, and z is about 11. So we put back to 3 power 2 plus 7 power 2 plus 11 power 2. And in here we can get the answer is about 179. The next one we have 4, 8, and 10. And so we put 4 square plus 8 square plus 10 square. That's about 180. So after we compare two values in here, we just select about this number, and now we can find that the minimum is 179 when x equals to 3, y equals to 7, and z equals to 11. And here is all the technique to answer the question. That's the end. Thank you for watching.